In May 1943, the German U-boat fleet collapsed in a single month. 41 submarines lost in 31 days. The Allies called it Black May. Dönitz pulled his boats from the North Atlantic entirely. The tonnage war, the strategy Germany had spent 4 years building, was over. But here's the part the official histories tend to pass over quickly. The submarine that caused that collapse wasn't a new Allied weapon. It wasn't radar. It wasn't sonar. It wasn't the escort carrier. It was a design decision made inside a German shipyard in 1935. A structural compromise that the engineers flagged, the admirals approved anyway, and 8 years of war could not undo. The U-boat didn't fail because it was hunted. It failed because of what it was built to be in the first place. Germany in 1935 was rearming under conditions it couldn't fully admit to. The Anglo-German Naval Agreement signed that June gave Germany the right to build a submarine fleet up to 45% of Britain's. In practice, the Kriegsmarine had almost nothing. What they had were plans. A handful of engineers who had spent the previous decade working in secret through front companies in the Netherlands and Spain, and a design lineage stretching back to the Type UB and UC boats of 1917. The man responsible for rebuilding that fleet was Karl Dönitz. He took command of Germany's submarine force in 1935, with exactly one operational U-boat under his authority. He understood that time, money, and the Treaty of Versailles had all conspired against him, and so he made decisions accordingly. The Type 7 was the boat he chose to build. It was not the most advanced submarine available to him. The Type 1 had come first, larger, longer range, better armed. The Germans looked at it, studied it, and decided it was too complicated, too expensive, and too slow to build in the numbers the tonnage war would require. They needed something simpler, something a yard could produce quickly, in sequence, with consistent quality. What they built was the most produced submarine in history. More than 700 Type 7s entered service between 1936 and 1945. The design was refined, uprated, modified. The VIIC became the standard Wolfpack boat of the Atlantic campaign. And it had a problem baked into every hull from the very beginning. To understand it, you have to understand how a submarine hull is built. In a conventional surface ship, the pressure hull, the part that holds the crew and machinery, is the outer hull. It faces the sea directly. You build it strong enough to handle wave loading, add some waterproofing, and that is largely the end of the structural question. A submarine cannot work that way. A submarine descends, and as it descends, the pressure of the water pressing inward increases at roughly 1 atmosphere for every 10 meters of depth. At 100 meters, that's 10 times the pressure at the surface. At 200 meters, 20 times. The hull is not resisting waves. It is resisting the ocean trying to crush it inward from every direction simultaneously. The pressure hull of a Type 7 was a cylinder. A cylindrical shape distributes compressive load evenly across its surface. No corners, no stress concentrations, no weak points. The engineers who built it understood the physics. The cylinder was sound. The problem was what surrounded the cylinder. The Type 7 used a saddle tank design. The ballast tanks, the tanks you flood to dive and blow to surface, were not inside the pressure hole. They were external, bolted to the outside of the cylinder. The saddle tanks gave the boat its characteristic silhouette, the rounded bulge running along either side of the hull above the waterline. This was not a radical decision. It was a conventional one. Saddle tanks had been standard on German submarine designs since the First World War. They reduced internal complexity, simplified the pressure hull geometry, and allowed more of the interior volume to be used for fuel, torpedoes, and crew. What they also did was create a gap. Between the pressure hull and the outer casing of the saddle tanks was free flooding space. Water moved in and out of that space as the boat dived and surfaced. That space was not pressure-rated. It was not designed to withstand significant loading. It was, structurally, the gap between the real hull and the skin the boat presented to the world. In calm water at moderate depth, this mattered very little. The Type 7's designed operating depth was approximately 200 meters. Its tested crush depth was somewhat deeper. Under controlled conditions, the design was adequate. The Atlantic was not a controlled condition. Depth charges set by British destroyers and aircraft did not need to crack the pressure hull to kill a U-boat. They needed to detonate close enough to buckle the outer casing, shatter the saddle tanks, and jam the diving planes. A boat that could not surface was as dead as one that had been split open, and the external saddle tanks, exposed, unprotected, free flooding, were exactly the surface area that a near-miss depth charge was most likely to reach. The engineers who built the Type 7 knew this. It was in the design notes. Dönitz was not ignorant of the Type 7's limitations. He had sailed in submarines. He understood depth charge attack from personal experience. He had been taken prisoner in 1918 when his boat was forced to surface under fire in the Mediterranean. He knew what a near miss did to a hull. What he chose to believe was that tactics could compensate for the engineering. The Wolfpack Doctrine, or Rudel tactic, was designed specifically around the Type 7's capabilities and limitations. Boats would attack on the surface, at night, in coordinated groups. Surface attack minimized the time spent submerged and vulnerable. Speed on the surface was 17 knots against 9 submerged. Dönitz's answer to a structurally exposed submarine was to keep it out of the water as much as possible. For 2 years, this worked. Between 1940 and the spring of 1942, the Wolfpacks sank nearly 3 million tons of Allied shipping. The system functioned. The boats attacked, surfaced, transmitted their positions, and returned to the French Atlantic ports at Saint-Nazaire and Lorient for refit. The tactical doctrine papered over the structural compromise. Then 3 things changed, and they changed in the same 12-month window. The Allies introduced centimetric radar, the H-2S and ASV Mark III systems that could detect a surfaced U-boat at distances the Germans had not thought possible. A submarine running on the surface at night, which Dönitz's entire doctrine depended upon for safety, was no longer invisible. The radar systems were small enough to fit in an aircraft. They were being fitted to long-range liberators patrolling the mid-Atlantic gap, the area Dönitz had considered beyond effective Allied air cover. At the same time, the Allies cracked the Enigma settings for the Atlantic U-boat traffic consistently enough to route convoys away from the Wolfpack positions. The boats were arriving at patrol areas that had been swept clean. Contact rates fell. Fuel was spent. Boats surfaced to transmit and were found. And the depth charge improved. The Mark 10 and Hedgehog ahead throwing mortar gave escort commanders the ability to attack a contact while still holding it on sonar, a capability that had not existed in 1940. The older pattern of dropping charges and losing contact for the re-attack run was replaced by something more methodical. The saddle tank vulnerability, which was a calculated risk under the old conditions, became a systematic kill mechanism under the new ones. Escort commanders were briefed on the Type 7's external ballast tank geometry. A near miss ahead of the saddle tank, close but not lethal to the pressure hull, was often enough to end the engagement. Dönitz understood what was happening. His war diary entries from April and May 1943 document it with the precision of an engineer who has finally run out of tactical solutions to a structural problem. He wrote that the boats could no longer operate in the face of the enemy's air and sea forces. He did not write that the design had been wrong, but the numbers he was recording were the argument he could not make in writing. In May 1943, he ordered the Atlantic withdrawn. The Type 7 kept building after May 1943. The yards at Bremen, Hamburg, and Danzig continued producing hulls because there was no political mechanism for stopping them, and because Donitz had been promised new technology, specifically the Schnorkel breathing tube and the Type 21 electroboat, which would change the conditions again. The Schnorkel arrived too late and was fitted too inconsistently to matter. The Type 21 arrived in combat-ready numbers in early 1945, one patrol. The war ended before the operational data could tell anyone whether the design had solved the problem or only deferred it. Of the 1,154 U-boats that commissioned and served in the Second World War, 783 of them were lost. More than 28,000 of the roughly 40,000 men who served in the U-boat arm did not survive the war. The casualty rate was approximately 70%. No other branch of any combatant nation's armed forces sustained losses at that proportion. A handful of Type 7s survive today. U-995 stands outside the Naval Memorial at Lebow on the Baltic coast. Visitors walk through the pressure hole, the cylinder that held, and can see from the inside exactly how little separated the crew from the external casing. The gap is smaller than most people expect. The dark part of this story is not that the U-boat was beaten. It is that the people who built it and the people who sailed it understood the margin they were working within. The compromise was documented. The risk was calculated. The decision was made that production volume and tactical doctrine would compensate for what the hull could not absorb. That calculation held until the Allies changed the conditions. Then it failed all at once, faster than anyone had prepared for. The Type 7 was not a bad submarine. It was an adequate submarine deployed by a doctrine that had no margin left when the enemy improved. Adequacy in war has a specific cost. If you want more of these stories, subscribe. There are more machines like this one.